Hey guys, how's it going? My name is Daryl. Welcome back to the channel. Today we're putting together a complete RSI divergence strategy using three simple signals. The first one is the market trends. We will use the exponential moving average to see if the market is going up, going down, or going sideways. The second signal is the RSI hidden divergence. This will help us to spot the subtle shift in momentum. The first signal is the stochastic oscillator crossover. This confirms those momentum changes with clear crossovers. When all these three conditions happen, it's a strong go signal, meaning that the setup is ready to trade, ready to enter. Now I will walk you through each step so we can build this strategy from scratch. Let's jump in. Here is a quick recap of where we are and what we've covered so far. The step 1 is the import required library. And then the step 2 is to initialize the MT5. And then the step 3 is optional, which is used to get the symbol from the file names. And then step 4b is to get the CHoCH LC data, that is the open, high, low, close data, and then calculate the ATR. Alright, let's rerun the code and review how everything fits together so far. In the last lesson, we showed you all these essentials library that we need to input. The first one is the MT5, and then the second one is the pandas and NumPy, and then we have the technical indicators, the pandas TA, and then we have the SciPy signal, which is to use it to detect the local maxima and local minima, and then also others like the date times and OS for managing the times and files operations. And then next, we are going to use the functions to initialize the MT5. This is mainly used to set up the connections to MT5 using your local login credentials and server informations. And then this corresponding to the step 2, where we initialize the MT5 so we can start pulling the data. And then next is the get symbol function. Just like what I mentioned before, these functions automatically select a trading symbol based on your file's name. And this link back to the step 3, which is that I stated that is optional because it allows us to dynamically to retrieve the symbol without manual changes. But if you are using you're going to deploy 1 or 2 bots, and then I feel like it's not that essential. But of course, if you are using multiple bots, and that is definitely very especially useful. And finally, we have the CHoCH LC functions, which is the functions to help us to capture the historical open, high, low, close data for the chosen symbols. And it pulls a specific number of time frame, 1 minute bars, converts the timestamps to a human readable date adjusted for the time and human readable date here, and then also adjusted to the local time zone. And then of course we also clean up the unnecessary columns and calculates the ATR. And this aligns with the step 4 that we have. And together, these functions set the stage perfectly for building our RSI divergence strategy. So now let's rerun the code and then to connect to the MT5 and retrieve some data. All right, now the connection is good, and then everything is fine. We are ready to develop the strategy. This is our overall setup for the RSI divergence strategies. that I also mentioned in previous episodes. It's based on three key components that help us to decide whether or not the market is ready for a trade. The first one is the market trends. This checks the overall directions of the market using the exponential moving average 50 and 200. And then if the close price is above these two exponential moving average lines, and then also the EMA 50 is higher than the EMA 200, and then we consider this is a trend bullish or the bullish trends. And then the second one is the RSI Hidden Divergence. This detects a momentum shift in the markets using the slope of hidden bullish or bearish divergence on the RSI indicators. A negative slope on the hidden bullish line indicates potential upward momentums. On the other hand, a bearish slope or a positive slope on the hidden bearish lines suggests a downward momentums. So what we're looking for is a bullish trend and then a hidden bullish divergence. And then the final one is the stochastic percentage K and percentage D crossover. This confirms the momentum changes by detecting when the percentage K across the percentage D, or on the other hand, for a bearish crossover, the percentage K is crossing below the percentage D, which provide additional information for entry or exit by using this crossover. When all these three signals align in the same directions, for example, bullish markets, we have the bullish trends, and then we have the hidden bullish divergence, and then we have a stochastic percentage K, percentage D crossover, or the bullish stochastic crossover, we will then get a to-go signal, to-go verdict, indicating a high probability sell-up. And then otherwise, this is a not to go trade. Now that we've covered the setup quickly, and then also the overall structure, let's start building the core of our trading logics. The first one is that we'll focus on basically it's the first 6 steps of the strategy flow, which lay the groundwork for generating a high probability trade setup. So what we're doing is that we will focus on these sections to create the strategy, and under this strategy, we will create 2 additional signals, that is the hidden divergence and also the stochastic crossover. Let's walk through this step one by one. In the step 1, we will begin by calculating the RSI using a 14 periods to evaluate the market momentums and spot the potential overbought or oversold conditions. And then we will use this RSI to detect the hidden divergence by comparing the RSI movements against the price trend, and this helps us to identify the bullish, the hidden bullish or the hidden bearish signals. And after that, we will calculate the stochastic oscillator, both percentage K and percentage D, using a 14 periods percentage K with a third periods movings to calculate the percentage D. And then after that, we will use these two stochastic values to detect the crossover. If the percentage K crosses above the percentage D, and then that will identify a bullish signals. On the other hand, if a percentage K crosses below the percentage D, then that will indicate a bearish signal. And then after that, we will compute the EMA 50 and EMA 200, which serve as our trend filter. This helps us to identify or to define the broader market directions, whether we are in an upward trend or whether we are in a downward trend. And then once we have the trends, we will confirm whether or not we will only do the long or we will only do the short. And each of these components will become its own functions, and then they all align. We will get a strong confirmations for entering a trade, which we will tie together in the final step later on. And that is the step 7. That is the to-go verdict. It's the decisions making logics that tell us whether to actually take the trade or not take the trades. This happens inside the main functions, where we continuously check for signals in real time. And the trace is only triggered when all these three conditions that I just mentioned align. And then this is the heart of the strategies. But since it ties everything together, it involves the real-time signal detections and also the trade executions. We will be covering this part in more details in a later episode. Now let's focus on building the individual pieces that fit into the final verdict. All right. So the first thing is that we would like to calculate the define the functions to calculate the RSI. So we are going to put everything inside a strategy. So we define a strategy functions. And then the first things that we are going to do is to calculate the RSI, and we are going to use the pandas TA, the RSI functions, and then we are using the closing price, and the time period would be 14, and then we'll fill the NA with 0 just in case if there are any NAN, and just returns the data. So that's it. So now let's work on the initialize the MT5 and then take a look on these functions. Here we use the Bitcoin as an example. Got a 250 bars, and then put inside this strategy. Here we go. And then finally, let's print the data. So now you will see your OHLC data with a new RSI column added. And now in the next step is that we're going to use these RSI to detect the hidden divergence. In order to detect the hidden divergence, we are going to use this was extreme functions to detect the peak and trough. So what we're going to do is that we are going to use the data.rsi.values and then check whether or not they are the peak or a trough. The first one is that we're going to set it up as a peak. And there will be 3 parameters that we need to provide for these functions. And the first one is the R rates that NumPy R rates that you would like to detect the peak or trough. And then here, because we are using the NumPy stock rated or equals, in that case, we are detecting the peak. And then here we have a orders equals to 14. This is used to control the window size for identifying the local extremer. A larger values means fewer but more significant turning point, and then a lower value may create some noise. So let's see what we can get here. Say for example, we use a test and then print the test here. And now you can see we just identified these RSI values, these time series RSI, that there's a peak happening at these positions. So basically, these functions returns an array of index, whereas the local RSI highs occur, or low, or where the local RSI lows occur. So in that case, we will use the ILOC functions to select the rows that have those peak indexes. And then, so in that case, we are using the ILOC here. And because this is an array, I just would like to retrieve the entire array first. So this is a index. Just like what I mentioned, that I would like to use the ILOC functions to retrieve the relevant or the corresponding RSI values at those peaks. And then here, this is the data that we have the peak. Remember that we are detecting the peak for the bearish divergence, and then we are detecting the trough for the bullish divergence. So now we have pull out those RSI, and then what we're going to do is to put it back, package them into this divergence function, and then 14 by default, package these functions, and then going to return the data frame. And what we need to do is just copying back this, and then add these functions in the main strategy. So here, and now you should be able to see there will be the trough and peak. That's showing the corresponding RSI. I remember this one happened at 33, something like that. So maybe show you that. You go, and you can see if we detect the local trough, or if we can detect the local peak, that is the local maximum and local minima, and then we will put those corresponding RSI in these two new columns. And then we are going to use these two columns to calculate the slope. So now just remove this. Yep, here we go. Now to help you visualize what we just did and how we identify those hidden divergence points, I've actually prepared a plot. So we basically use them, everything's are the same. So we basically just plot out what we've just did. I will skip the code here, but basically after calculating the RSI and running our hidden divergence functions, we plot the RSI as a blue line here, and then the upward red upward triangles marks the hidden bearish divergence points, and then on the other hand, the green downwards triangles shows the hidden bullish divergence points. That is the local minima. And then by spotting this peak or trough on the RSI curve, and then we can now have a better, clearer pictures of where the momentum is likely to push next. Just like what I mentioned, there's a period or the order number, not period, order numbers to control the window. So say for example, if I just change it to 2, and then you can see there will be more peak and more trough here. So in order to avoid too many noise, we will use 14 here. All right, now that we've identified the local peaks and trough in RSI, the next step is to calculate the slope between these trough or between these trough or between these peaks. So the reason is because the slopes tell us whether or not the RSI is making higher highs or lower lows over time to confirming the hidden divergence. So here is how we are going to do. First of all, we just use the same functions, use what we just create. And then what we're going to do is to calculate the slope inside these hidden divergence functions. So first of all, let's take out those value of from the H-bear or H-boost. The first thing is to get the bear divergence. What I would like to do is to take out those non-null value. You can see there are a lot of nulls here. So what we're going to do is just pick up the non-null value. That is not null. And then we just take out those values to calculate the slope. And of course, these non-null value are the y-axis, are the x-axis, and then that is the y-axis, that is the RSI value. And then we need to understand the step in order for us, the x-axis values in order for us to calculate the slope. So in that case, we are going to create a column called steps. That's actually give us the difference between their index value. So we basically just pull out those index value back to this EF slope pair step. So now we can calculate the slope. That is the H pair slope, which is the H pair pair, that is the difference, and then divided by the steps difference. And then we are going to put it back, use the concat functions, put it back to the data frame. Put this back to the data frame. Just concat, and then by column, we need to reset the index according to the original data frame, that is the data. Now let's take a look and see what we get here. Now we just calculate the bear slopes according to the RSI, but to better show you what we've just did, this is a hidden divergence, and then let me return you the slope. You go. Now you can see we are actually taking out the peak value, here, and then for the peak value, what we do is to calculate. We also pull out the corresponding index, that is their corresponding index, and then we calculate the difference between this value and this value and this value and this value in order for us to calculate the slope, that is the y1 minus y2 divided by the x1 x1 minus the x2. And then we will then calculate and then we will put out all the slopes in this column here. And then just like what I mentioned, we just concatenate everything back to the original data frame. So I will just remove this. And now we will move on to calculate the bull slope. And I will just simply change everything here. This is the bull, and then we're using this trough. We're using the trough. And then the trough, and then this one should be the bull, Just make sure I'm doing everything correct. Not now. Nice. And now we should have another slope calculated. Let's run the cell. And here we go. We have the bear slope and also we have the bull slope. So what is this slope tell us? Just like what I mentioned at the very beginning, we would like to use this slope to detect the hidden bullish or the hidden bearish divergence in different market conditions, of course. And now, to help you understand how we detect the hidden divergence, I've also created another chart to show you what we just did. The codes are the same, but of course I've created a plot here. On this chart, you can see the blue line representing the RSI over times. And then here, previously we identified the peak and also we identified the trough. And then the wet upward triangles marks the hidden bearish peaks. Those are the local maximas for the RSI, where the markets might reverse or continues downward. On the other hand, we have the green downwards triangles here, which shows the hidden bearish trough and the local minima of the RSI, where the price might continue upward. But here's the most important part. We don't just identify these points, we also connect these consecutive peaks or trough with lines and calculate the slope between them. For the bearish peaks, the lines connecting the peaks are colored red here. If the slope is positive, meaning that the RSI is rising between those peaks, or gray, that is or gray if negative. On the other hand, for a bullish trough, so the connecting lines are colored green. If the slope is negative, that means the RSI falling between the 12 or gray if that is a positive. And next to each line, of course, you will see a small numbers here. That is the slope valued rounded to 2 decimal value here. This slope just tells us the rate of change between the two turning points. And then once again, a negative slope on the bearish peaks signals a hidden bearish divergence. On the other hand, a positive slope on the bullish trough, signaling a hidden bullish divergence. And in this case, the red line and also the green lines are what we are looking for. In the next episode, I will walk you through how to calculate the stochastic oscillator and spot the crossover signals. Thanks for watching. See you in the next video.